Good morning, everybody, and welcome. It's a pleasure to be here, to this wonderful place. So I'd like to thank the organizing committee. And I'm going to tell you a little bit about my work. I'm an electrical and computer engineer, but I've been in the interface between computational neuroscience and machine learning for many, many years, and I'm going to give you my view of this interesting comparison between natural versus artificial intelligence. See if this works. So, it turns out that brains are in fact required as an edge to survival. That's the reason why, biology evolved into brains. And all animals that are sufficient intelligence that move on Earth and in the oceans, they have some form of a nervous system. The nervous system is a combination of cells called neurons, and neurons talk to each other with very tiny impulses of current. And I have here a video from YouTube that from the zebrafish. Turns out that the zebrafish is amazing laboratory because it's transparent, and so we can effectively see how neurons are talking to each other. These points of light that you see in this movie are exactly neurons that are firing subject to information that comes from the senses. And so you see that the brain, most of the time, the neurons don't fire, and all of a sudden there are bursts of activity like this one that really conveys information that, from the external world. So if we look how brains evolved, brains have been invented several times throughout evolution, but they appear about 500 million years ago. And they have progressively become more and more complex in the vertebrates and also, in particular, in the mammals. Right now, the most complex brains are in the mammalian brain. However, there are other types of brain architectures, like the octopus, for instance, that is unrelated to the way our brain evolved, but is also very, very, accurate. But it turns out that our brain still preserves the essence of the previous versions of brains. And that is one of the difficulties that we have, is that we have this mixture of rationality and emotions that is part of ourselves as humans. And inside our brain, we still have parts of the brain that is like the salamander. What is that thing? Some of you may know what is a salamander, so you still think like a salamander sometimes. It turns out that human brain is made up of about 10 to the 11 neurons. Each neuron has about 10,000 connections to other neurons called the synapses. So this is a very, very complex system. And it turns out that I think that a very important question that I think we should address is, what is the origin of the knowledge that we have in our brains? We are very proud of the knowledge, the way we think. But the question is, where did it come from? And I think that we have to answer this question. There are three fundamental pieces of evidence that impacts the knowledge in our brain. The first one is the one that we don't think about, but is the DNA. Because the DNA effectively builds our brain. And it turns out that there are not enough information in the DNA to connect specifically one neuron to another neuron. So that it means that there is a really big difference between our brains because there is not sufficient information in the DNA to effectively do a one-to-one mapping of neurons. This picture is a piece of a brain preparation. The colors are coded by different types of neurons, and you see that there is some information from neurons that go from point A to point B. And this is the DNA controls this, but the specific connections effectively are kind of dependent on how our brain evolved in ourselves. The communication between brains or neurons is made through the synapses. Synapses kind of weight the communication from one neuron to the next neuron. And this is the other very important part of knowledge that we have in our brains. We adapt our system since birth. Okay, so this is what fundamental part of the knowledge that we have is the adaptation of the neurons that has been done through our interaction with the world. And in fact, there is a specific cycle that is called the perception-action-reward cycle that really is the most important component for the adaptation of the synapses. And it turns out that without our body, our brain would know nothing. So it's a very interesting thing that we know the world through the brain knows the world through our body. And Edelman, that is a Nobel Prize for computational neuroscience, said this sentence that I think is very important. The brain is embodied and the body is embedded. That means that our brains understand the world through the body, right? And Damasio, that is a very famous cognitive scientist, Portuguese, he is also one of the proponents of the embodiment of the brain. Of course, the third aspect that I think is important to when we talk about knowledge in our brain is exactly what we have, the evidence that we have collected in our society in the forms of culture, books, and now the web. So you see that if you ask me, I think the brain is basically a huge memory store. We have lots of information in the brain that has been organized by ourselves. And it is also very efficient. Our brain takes about 15 watts of power, all right? And so it's extremely efficient, and we use it in real time every day, right? So the next question I think is important to ask is, what is intelligence? All right, and I'm going to define intelligence in very broad terms. I think everybody understands this ability to solve problems that have not been encountered before. So sometimes during our lives, everyday situations, we encounter problems that we don't know how to solve. And then this is exactly the intelligence, is the process of finding a solution. But this not happens all the time. So most of the times we are simply reacting to events and simply, taking advantage of the storage that we have in our brain. So the amazing thing about brains is they are real-time, and they are adaptive. They are self-organized. In fact, we know that the elements of the brain are non-linear, and this becomes really a huge distributed dynamical system that we carry with us every time. Of course, this seems very much like a computer, and it is a computer, but is exploiting not silicon technology that we use in our own computers, but carbon technology. All right, so we are computers made of carbon, all right? Remember that. So we don't compute with numbers. What we do, we use context, attention, goals, and these are the components that in fact lead us to create brain states and interpret the world. And we interpret the world in an active manner. I normally say that we see what we want to see. And this is very different from the computer vision and computer vision approaches that are passive. And it turns out that the brain has the ability to talk to itself. And this is really what is the process of confabulation that leads to reasoning and exactly to imagination. So we have the ability, our system kind of talks to itself in the self loop, and this is really what we do when we reason. And what is interesting is that since the essence of the information in the brain is extracted through the world, we effectively have the logic of physics embedded in the organization of the brain. And so natural intelligence just abstracts principles from facts and applies them based on context and goals. So this is really what is natural intelligence. And let's kind of contrast this with artificial intelligence. That is a totally different discipline. And so, by definition, we can say that AI is the design of machines that think and learn. It all started as formal systems. Formal logic and propositional calculus and the Church-Turing hypothesis in 1936 really gave rise to the formal systems. The first AI research project is very interesting, was exactly to try to model the brain as a computer. And this is the famous McCulloch and Pitts model of the neuron that was done in 1943. The big person that really was able to move AI into research was John McCarthy. And from the 60s in England. And he was one of the leaders that really started using artificial intelligence exactly to help the humans work with data. And AI has suffered up and downs. Of course, now we are in an upswing. There has been also downswings in AI, and the expert systems in the 80s is really a good example of that did not work in the real world. But currently, AI is really a disruptive technology and a buzzword, okay? And in order to find out how we get there, I think we should go to 3 waves of technology. So the first wave of technology that has started is the Industrial Revolution that took about 150 years. It started in 1750, and it is related to the steam engine, the internal combustion engine, and of course electricity. This was the big motor for the first Industrial Revolution, and it impacted transportation, communications, urban centers, and even created the fabric of today's society with salaried workers. Workers did not get salaries before the Industrial Revolution, and we kind of forget about that. Anyway, so the benefits was economy of scale. The side effects was that they were resource intensive, and there was a huge environmental impact. The second revolution that I mentioned here is the Internet revolution. And it's interesting that it took only 30 years to get in so you see the cycles are coming shorter and shorter. That means that the evolution society is really accelerating. And it turns out that in the Internet revolution, the big issue was the existence of the mainframes, the big computers, and the communication between big computers using our communication systems that we send data between the computers. And this really transformed analog enterprises in digital enterprises and open networks that we still use today, like the web. And this allowed exactly e-commerce. But it is really, the Internet revolution is still information and knowledge intensive, so we are really at the point that we need something else. And something else is what I call the intelligent Internet that started around 2005, and we are in the beginning of this new era. And what happened is that now we are interconnecting devices, but the devices themselves are intelligent. So we have intelligent distributed systems, and they generate big data, and they drive predictive modeling. That is the way that we are actually using this in the industry today. And so this is the reason why, and I think it's important for us to find out that the place where we are is a convergence of technology that we have to remember, that they are needed to effectively have artificial intelligence. Sometimes we just think that AI is what matters, but AI does not exist alone. AI requires that we have sensors to collect data in the real world. And this is what is the Internet of Things, right? And it turns out that now there are more devices connected to the web than humans on Earth. So you see, this is a pulverization, of devices that we have and that we are going to continue to have. And these devices are going to collect data, and we need to do something with this data. So the cloud computing, that is this big, big mainframes that are distributed across the world, and that we call now cloud computing, is they process this amount of data. And of course, we have to manipulate this data, and we are creating an amazing amount of data. This I'm sure that now is more than 2.5 exabytes per day, but exabyte is 10 to the 18, 10 followed with 18 zeros. And we are creating this amount of data every day. And so if we have to create this data, we have to store this data, we have to recall this data, manipulate the data. And once we do that, then we are able to start extracting information from data. This is really what matters. Because the data is important, but really what businesses and ourselves are interested in is not the data, is the information that data contains for predictive modeling. And this is exactly what AI is providing. And there is a lot of techniques that I'm not going to mention in AI, but the core of those techniques is that they transform data into information that is manageable. And that is because information is something that we can hold to and process. And this is really what I call the intelligent internet. Now, just a brief slide to tell you those companies that are interested in using AI in their businesses. You have to remember that AI has requirements to be useful. And so there is kind of a pipeline that you have to remember. And it starts, as you may predict, with data. So if a business does not collect their own data, can never get AI to work with. So I think this is something that you have to remember. And data, you have to store the data, you have to curate the data, because if the data is not good, AI applied to that bad data is not going to give you good results. Okay, so there is really here a step-by-step procedure that has to be implemented, such that then we can use our programmings, the AI methodologies, that are in the third column: machine learning, fuzzy systems, evolutionary algorithms, speech recognition, automatic translation, and things like that. And we can then encapsulate these programs and make them useful in the industry, for the Industry 4.0, or augmented reality, as we have seen, and the medical diagnostics, I think, is a fundamental area, and it will be in autonomous vehicles and in cybersecurity. So let's now analyze a little bit why the buzz. And I think that in order to understand why we are so much interested in AI, we have to look at it from an evolutionary perspective. I think that the ecological success of the human race is intertwined with tool building. Okay, so tools are fundamental, have been fundamental in our evolution as a species, and it created, in fact, and creates wealth that we use in our societies. And this started with hunting, and then we go to farming, housing, manufacturing, and this is really the way we develop tools. But there is a very interesting thing, is that there is a master-slave relationship between ourselves and the tools we build. We build tools, but we are the masters. We use them, okay? And it turns out that has been all along this way, but for the first time that the computer made decisions that did not have the human in the loop happened exactly during the World War II. So it was the first time that the computer made a decision that the human was not in the loop. And this started a revolution that gave rise to the artificial intelligence boom, the machine learning boom that we are actually living today. And I have to agree that there is a lot of buzz, probably too much, but we are humans are fashionable persons. And so if we have fashions for clothes, we also have fashion for technology. Now the fashion is AI, okay? But I don't think we should discount the importance of AI. The first question that we have to ask is this going to continue? And absolutely yes. I think there is no other hope. And the reason why I'm so certain is that it turns out that technology is becoming more mind-centric to try to compensate a feature of our body and brain. That is, brains are internal representation systems. Brains are for you to use. And this creates a problem, right? Because I told you that we have brains because of survival, but to enhance survival, humans also start living in groups. And then this creates a problem, because when you live in groups, you have to talk to the other person, right? But your brain is made for you only. So brain had evolved to exactly with what was the big jump from monkeys, from primates to humans, was exactly the ability to speak. Okay, so voice is now our most effective communication. But if you think about it, you can only tell 20 words a minute. If your cell phone would use 20 bits per second, what would you do with it? Nothing. You just throw it out. So this is the fundamental problem that we have as a species, I think. Our problem as a species is that we now live in groups, but through evolution, our brain is for us. And so how can we handle this problem? And I think we have been handling it since we started working or living in groups with culture and language. The culture is fundamental because the culture gives you the context for which one word means a lot. Okay, so the ability to have cultures is to give us context such that one bit of information is very meaningful. Okay? And of course, from this point, what we did is, of course, we start writing what you knew. Society start writing what you knew in books, and then with the press, and now the computers, and now the World Wide Web, right? So you see, there is an evolution here, technological evolution. This is simply making knowledge more accessible. And in fact, what I think is happening on the web today is that the digital technology is creating an external repository of knowledge that everybody in the human race can access. And so in my view, the technology becomes more and more mind-centric because it's an evolutionary necessity for the human race, okay? Sorry. So I think that this step of using AI and do computation and extract information from data is in this line of thought and will continue to be useful, okay? And so now let's go back to human versus machine reasoning, and I will stop in 3 minutes. I think we all agree that humans and machines think very differently. But my idea is that we should use both types of intelligence in a synergistic manner, instead of being one versus the other, as sometimes appears in the popular press, that computers are going to take over and things like that. I don't think this is going to happen. I think what is going to happen is that we synergistically are going to utilize both types of intelligence. And humans shine at intuitive decision-making, while computers are excellent in analytic skills. I told you that the human brain uses 15 watts of power. This is an amazing thing that we carry with 15 watts of power, millions of calculations. But AI opens the door for automation of information processing in structured domains. And just to give you an example, the fastest computer currently is the Chinese Sunway, and it consumes 15 megawatts of power. So our brain uses 15 watts. The Sunway uses just 1,000,000 times more. And it does, of course, many megaflops, or pentaflops, 93 petaflops. Penta is 10 to the 15. So 10 followed by 15 zeros, right? Floating points operations per second. But it takes a huge amount of power, and there is a lot of people that are worried about the power that the AI is going to require in the future. So, just to give you kind of the context of where I think that AI, the type of problems that AI is going to help us, is obviously in decision making. More and more, the big issues are related to the processing of information. And decision making is difficult, and it's difficult by many different ways, okay? Because it's a mix of knowledge, intuition, and deduction. So these three things are intermixed in our decision making. And when the complexity of the problem is in the amount of data, in the dimensionality of the data, I think that AI is the perfect technology to help us decision making. Okay? However, there are other difficulties that are not, the complexity is not the issue. Sometimes it's the uncertainty that is the issue, the difficulty. And when we talk about uncertainty, that means that we have insufficient information to make decisions, or we have noisy data. And in that case, AI is already providing quite a bit of tools, but the ambiguity still has to be rather low. If the ambiguity is very high, don't look at AI solutions. And in my view, they are not the only two types of problems that are difficult. There is another type of problems that I call equivocality, where you have conflicting interpretations for a given situation. You don't know if what is happening is because of this variable or another variable. And in those cases, AI really has a very, very reduced set of tools to help us solve this type of problems. So this tells you that AI is not the ultimate technology. AI is going to continue to evolve, exactly to help us increase our chance of survival. And this last slide is just, I'm always asked when I talk about these things, do you think that the robots are going to take over? Right? And I think, no, it's not. I think that what is going to happen, as I already expressed, is that I think that there's going to be a synergistic relation between humans and the robots. And with this, we are going to improve our ability to comprehend problems for which our brain is small enough. And so, like the complexification of human society and also of our technology, so I think that what I predict is that the machine intelligence is nothing but another enabler of innovation. And it will continue to change everything in our societies, from jobs, processes, enterprises, social and political doctrines. And the hope is that it's going to give us an added edge for survival of the human race. Thank you very much for your attention.
You mentioned that you don't believe that technology and computers will take over working places. Can you comment on this a bit? Because I have a contrary opinion. Yeah. It's a good idea to use technology.
Yes. All right. So the question is, if I really believe that robots are not going to take over. Yes, and I believe that. Because the way that the robots are being, programmed, first of all, we programmed the robots, okay? That's the first thing. Second thing is that robots are programmed in very structured environments, because we do not know yet how to do robust AI in unstructured environments. So everything that you see from the factory floor to other applications of robotics and in machine learning, they are in very well-specified tasks. And for those tasks, they are much better than we are. You understand? But there are tasks that we cannot circumscribe. The more data, there are tasks that when you bring me a new data, you are going to change the solution space. And if that is the case, current AI technologies are not able to solve those type of problems, because data does not solve the problem. You understand? So it's a detail, but I will be happy to talk to you a little bit more about this. But I really think that our current use of AI is in very specific niches, well-defined niches, that have been, where computers do a much better job than we do. But if your problem is, if you have conflicting evidence, and you put an AI robot trying to solve this type of problems, the solution is going to be ugly.
However, anyway, amount of humans working physically will be decreasing immensely. So for this type of problems to solve, which you mentioned, we just need little amount of people.
Yeah, because you have the intuition, you have the context about the situation. And a computer is not able to tell you, I don't know.
Yeah, so
because when we say, I don't know this, that means that you have a very good idea of what is your limit of knowledge. And that comes because you have an holistic understanding of what you have applied, because you have experience. You understand? Computers are not programmed that way.
you say that technology will decrease, actually will increase unemployment, but not until the end. Still will have some people who will need to...
Yes, we are going to synergistically work with them, right? So the role of what I think is happening already is the role of humans, right, has changed, you know, more and more into understanding of the data, right, and making judgment about the data, how to strategically use the information and things like that. This is where I think is going to be the role of humans in this society of the future. You understand? So there's hope that you still will be in control.
Thank you.
All right, other questions? Since there's time for questions, yeah.
Hello. You spoke about that technology allows us to survive, and nowadays we are facing a really great challenge. Maybe one of the greatest challenges we faced as humanity, that is the ecological crisis and specifically the climate change. And I would like to know how can we put the technology and AI the service of our own survival for that matter.
Sure. I mean, so the complexity that you mentioned, you know, the problem of living in a world with limited resources, basically that's what it happens. You know, the scale of human intervention on Earth is such that we are changing the resources available, right? And they are finite. So the problem that we have to solve is exactly one where you have a very complex problem, right? Because you have an enormous amount of variables, of high dimension. And this is the type of problems for which AI is going to provide solutions. Like for instance, in weather prediction right now, a lot of the issues that is a very difficult problem, AI is already playing a very important role. So but of course, what we have to do is we have to have policies. We have to have, the interest in solving these problems as a human race. This is not a problem of a country. It's a problem that we all together should look at the issue of the depletion of resources on Earth collectively as a race problem. We are endangered. But in order to solve this, I firmly believe that AI is going to have a very important role, because otherwise the problem is too complex for us to solve it. You understand? Mm-hmm. So AI is going to provide us the tools for us to make predictions that can curb or correct exactly the exaggeration that is currently happening. You understand?
Yeah, thank you.
So it's a technical help, right? It's a tool. But we are the ones that have to decide to attack the problem. Right? Other questions? All right, thank you.